Our senior design project is the SearchBot. It is a proof of concept design with the premise of providing more automation in outdoor environments. Our approach includes an autonomous four-wheeled platform, a smartphone app user interface, and a radio communication box that allows the user app to communicate with the platform long distances. The project also features ultrasonic distance sensing for collision avoidance, which is necessary in real-world environments.
Our design requirement of a battery runtime of 30 minutes was met and exceeded by 28 minutes. When performing preliminary testing, we used cling wrap to protect the hardware from any water and dust. We designed an enclosure and front plate with holes for the front sensors. Inside the enclosure, mats were designed to prevent unwanted torque on the sides of the boards from mounting and to permit airflow.
The custom PCB incorporates the microprocessor, GPS, compass, and transceiver all into one unit. To control the wheel motors, we chose a Pololu dual VNH 5019 motor driver. A ribbon cable is used to communicate between the processor and the motor controller. Additional wires are ran for connection with the distance sensors.
The radio link uses Bluetooth to communicate to the user the bot's current position, heading, and the motor's condition. Communication with the bot is achieved through a transceiver, a board called RFM22B. It has a range of 200 feet. Total control of the system is achieved through an Atmega 328 chip. The chip will be programmed to perform control of all communication. All electrical components are designed to be mounted on a single PCB.
RoboRemo was used to create a preliminary design for communication with the radio link and is shown here. It tracks current, location, and accepts user input. It is then transmitted to a counterpart receiver on SearchBot to give it the target location. The transceivers will also allow for feedback from the SearchBot transceiver to the radio link transceiver and from the Bluetooth module back to the RoboRemo phone app. They convert signal received from the phone app into an RF signal.
SearchBot employs two front-mounted ultrasonic distance sensors for collision detection. When an object is detected, SearchBot will interrupt normal operations in order to avoid collision. The spacing of the sensors allows for better detection of obstacle edges. We are fine-tuning algorithms that allow SearchBot to efficiently navigate around obstacles in its path. SearchBot can calculate its GPS coordinate to within 3 to 5 meters under good operating conditions. SearchBot's digital compass is accurate to within a plus or minus 3-degree angle. Inclement weather can also disrupt valid GPS data acquisition.
Testing of individual subsystems has been successful. Complete integration of all subsystems working at the same time has not been achieved. The largest barrier at this point is the compass performance. We have realized that the magnets in the drive motors are interfering with the Earth's magnetic compass and are skewing the output. We are currently developing a workaround for this problem. Our group consists of Nathan, responsible for programming and testing, Josh, team lead and responsible for PCB fabrication, Anthony, responsible for user interface and subsystem integration, Andre, responsible for 3D enclosure, testing and mechanical systems, Ken, responsible for radio link enclosure and PCB fabrication.